All right, so we're just going to kind of add a little bit on what we did yesterday. Today's really pretty simple, too, kind of along the same lines. I think probably the biggest thing today, yesterday we spent a lot of time, some of the time talking about the measure of an arc. So remember, I'm talking about the measure of an arc. You're really just talking about the angle measure to the corresponding interior angle. So when you're talking about the measure of an arc, it's an angle measure, I mean, really, for the most part. Which, if we're thinking of practical applications when you're going to use this in your everyday life, but I will have you guys know, I use math every single day in my real life. I'm a math teacher. I use math every single day in real life. Anyway, but if you really think about a practical application here, you probably don't really care. Not as useful to know the arc measure. If you really need to know something about the part of a circle, you probably need to know like the actual length. I mean, right? That's what we're going to start talking about today. Not the measure of an arc, but the length of an arc. So if you were to actually take a tape measure and measure it out, how long would it be? So that's going to be kind of what we talk about today. Before we talk about that, we're going to spend just a little bit of time talking about what's called a concentric circles. Concentric circles. Okay, so concentric circles, they're going to be coplanar circles. So when it says coplanar, it just means they're on the same plane. You don't have like one flat and the other one vertical, okay? Or even like tilted. They're flat circles, they're on the same plane, and they're going to have the same center, so they're kind of circles inside one another. We're going to use this idea of concentric circles to solve word problems! Yeah. I know, man! You're like excited for this. I can just feel it. So, anyway, you have one word problem. That's it. And it's going to be really similar to this. So this car has a circular turning radius of 16.1 feet. The distance between the two front tires is 4.7 feet. How much farther does the outside of the turn travel, the tire on the outside travel than the tire on the inside? So kind of to paint a picture here, you got a car, right? And you're just like seeing how tight you can turn the car, okay? Now when this happens, you can't just like completely turn the wheel or because it won't go in like a perfect circle, okay? So you're trying to figure out that, okay, if you were to turn this car, right, as much as you possibly could, it would create a circle. The radius of that circle is called the turning radius, okay? But here's the thing, that's like the outside of the car. So that circle is the outside wheel, okay? And it says that is 16.1 feet. Okay, so that green circle is the path of the outside wheel. The inside wheel is going to be inside. It's going to be a smaller circle. It's not going to be quite as big, okay? What I need to do is, I'm talking about distance here, so I need to know the distance around the outside circle. I need to know the distance. What would that be? A vocabulary word here. Circumference. I need to know the circumference of that green circle. Okay? And I'm also going to need to know the circumference of the orange circle because that's going to be the distance that the inside tire travels. Now, to find the circumference of the outside tire, to find circumference, you either need the radius or the diameter. I have the radius of the green circle. So we're going to do 2 pi r, which is 16.1, just like we did yesterday. We'll leave the pi as pi, but we'll take 2 times 16.1. We'll get 32.2 pi. We'll leave it like that for right now. So in one turn, that's the distance that outside tire is going to travel. Okay. Now I need to find the distance that inside tire is going to travel. So I'm going to need either the diameter or the radius of that inside circle. But the information they give me, they tell me that the distance between the two front tires. So this distance right here. That is 4.7 feet. That's not my radius. That's not what I'm looking for. But can I use that? Is that a radius? So what do I do? Yeah, right? We take the 16.1 minus the part where they, right, that kind of overlap there. So 16.1 minus that 4.7 is going to give you 11.4. So the radius of the smaller circle is going to be 11.4. So then I can find the circumference of the smaller circle by doing 2 pi r. So 2 pi times 11.4, which is going to give me 28.8 pi. So I have the two distances. I know they look kind of funny because they have pi in there. But if the outside tire traveled that far and the inside tire traveled that far, 22.8. There we go. Okay. If the outside tire traveled that far and the inside tire traveled that far, how can I find how much farther the outside tire traveled? Yeah. Just subtract them. You're going to take 32.2 pi minus 22.8 pi. Okay, now, one thing. Pi, it's a number. It's not a variable, because a variable is an unknown value. We know what pi equals. It's about 3.14, yada, yada, whatever, okay? It is a value. It's not a variable. But in problems like this, you can think of it as a variable. So just like if you were to take 32.2x minus 22.8x, you would get 9.4x. This would give you 9.4 pi. Okay, so it's not a variable, you can kind of treat it as a variable. And then if I wanted to estimate, if you plug that into your calculator, it would give you about 29.5 feet. 29.5 feet. Which is kind of crazy to think about. Right? 30 feet? That's kind of a long ways. That outside tire travels more than the inside tire. Crazy, right? Yeah? No? Okay. Yeah, I know. Okay. I know. Maths, that's crazy. I know. What do you find today? Okay. The other thing we're going to do today is, like I was talking about, that we're going to talk about arc length. So the first thing we've got to be able to keep separate is the difference between arc measure and arc length. Arc measure probably isn't all that useful. Like if you were actually trying to do something with this, you probably don't really care a whole lot about the measure of the arc, which is the same as the corresponding angle measure. What you probably need to know is how long is it. You need to know the length. Well, and I think the formula looks kind of complicated, so I think it's easier to kind of talk about it first and then come back, and then I'll explain the formula. So let's say I have this circle, and I just wanted like a chunk of this circle. I just want to know how long just a chunk of the circle is. I could find the length of the entire circle. How would you find the length of the entire circle? It's a circumference, right? You would either do 2 pi r or you do pi times diameter. Right? So you can find the length of all of it. Now, instead of like subtracting that little part of it, I want you guys to imagine this. Let's say I just wanted this semicircle. I just wanted half of it. If I just wanted half of it, what would I do to the circumference? You would just multiply by 1/2, right? Does that make sense? If you just wanted a quarter of it, you multiply by 1/4. Because you're talking about a fourth of a circle. Now what happens here is we may not be talking about a quarter or a half. We may be knowing that, okay, this angle measure is 25 degrees. And I want this measure right here. If that angle is 25 degrees, how could I write what part of the circle I have? It'd be 25 over, 360. Because the whole circle is 360 degrees, I've got 25 degrees of it. So you would take this times the circumference. Does that make sense? So we can find the whole, find all of it, and then figure out how much of the piece of the pie you have or you're looking for. Okay, so like I said, I think the formula sounds a little more complicated than that, but that's all it is. It's finding the circumference. You can either do 2 pi arc or you can do pi times diameter. And then the measure of arc AB, right, over 360. That's the part over the whole multiplied by the circumference. That's all we're doing here. Okay, so let's try this one here. Now this one, we are wanting to find the length of arc XPY. So up here it's the arc in red. So we're going to need 2 things. We're going to need first the circumference. We do need the entire circumference. So to find circumference, you can either take pi times diameter, or in this case, since I have the radius, we're going to do 2 pi r. So 2 pi times 15, which is going to be 30 pi. So if I was going all the way around the circle, it'd be 30 pi. Okay, but I'm not going all the way around the circle. I don't want all of the circle. So then I need to figure out, well, what part of the circle am I talking about? How much of the circle is that arc? How many degrees is that arc? It's a 240 degree arc. You guys see that? It's 240 degrees out of what would all of the circle be? 360. You're going to take that, the part of the circle, times the entire thing, because I don't need it, I just need a part of it. Okay? Now, I think most of the ones on your homework are going to work out kind of nice and easy. The ones in our examples don't. But let's go ahead and we can probably just reduce as much as possible. So let's chop off a 0. 24 over 36. What about out of 12? We get 2 over 3 times 30 pi, which would be 60 over 3. 2 times 30. 60 over 3, which would be 20 pi. And what's my unit's going to be? Still just centimeters, because we're just talking about a distance. So it'd be 20 pi centimeters. This is the new part today. Similar to what we did yesterday, just kind of adding a little bit. Okay, let's get this glued into page 43. This is section 10.6 continued. All right, so first one, we want to find the length of the arc shown in red. If you don't have a red pen, that's fine. Maybe just kind of like scribble over, make the arc that we're looking for darker. So let's draw our circle. For this first circle, we're going to draw the diameter. And then we're actually going to draw a perpendicular radius. And we are going to want to find that arc right there, the measure of that arc. And the diameter is going to be 9 centimeters. Okay, I think I kind of like to do it in pieces just so it kind of makes more sense. So we're not necessarily memorizing a formula. We don't really need a formula because we can just kind of think through this. I want to know, I just want to know the circumference of just that part. So let's start by finding the circumference of the entire thing. This is the diameter. So to find the circumference, just take pi times diameter. So this circumference is going to be 9 pi. So that's if I were to go all the way around the circle. But I'm not going all the way around the circle. I'm just talking about that chunk of this circle. So the next thing we need to do is figure out, well, how much is that chunk? What portion of that chunk is it of the entire circle? What is the degree measure right there? It's 90, right? It's a 90-degree angle. It's a 90-degree arc out of, what would the entire circle be? 360, right? 90 over 360. You're going to multiply that by the entire circumference. And I think the ones on your homework end up being a little bit nicer answers. But for these ones, just in your calculator, we would take 90 over 360 times 9. I'm going to leave it in terms of pi, so don't plug the pi in there. But if you were to multiply all those together, you would get 2.25 pi. And then remember our units is just going to be centimeters. Okay, number 2. We'll draw our other circle. This time we're going to draw the center. And nice little chunk right here. And we want the length of that arc right there. Once again, gotta kind of keep separate the idea between measure and length. Length is if you were to actually walk it, right? Measure is talking about the angle measure. Okay, and this dimension here is going to be 4 feet. And this measure here is going to be 100 degrees. So I'm wanting to find, like I said on the last one, I'm kind of wanting to find the circumference of just that part. So let's start by finding the entire circumference. How would I find the entire circumference for this circle? Which of the formulas? Pi times diameter or 2 pi r? I have the radius, so we're going to take the circumference is 2 pi r. So 2 pi 4, which is going to be 8 pi. But that's all the way around. I'm not looking for all the way around. Now we're going to say, okay, well, here's how much of the circle I'm talking about. How much of the circle is this arc? 100 out of 360. 100 out of 360. You're going to multiply that by the entire circumference. Once again, I think the ones on your homework end up being a little bit nicer answers. You're going to have to round on this one. If you plug that into your calculator, you should get about 2.2 pi feet. 2.2 pi feet. Okay, I got a couple more for you. All right, number 3. Another circle. We're going to do a center again. We have just kind of a tiny little slice this time. This time, we're looking for that major arc. Okay, for this circle, the radius is 10 inches. And then this arc measure, the little one, is going to be 28 degrees. Now, kind of the same first steps. Even though we're looking for the major arc, I still need to find the circumference. What will I do to find the circumference of this one? 2 pi r, so 2 pi times 10, which would be 20 pi. Now, I will admit, if you look at my notebook, I had to kind of scribble some things out because I totally did this one wrong. Because what I did is I said, okay, 28 over 360 times 20 pi. What's wrong with that? Yeah, that's looking for that minor arc. I'm not looking for the minor arc. The minor arc is 28 degrees. That's not the major arc. How will I find the measure of the major arc? I have to take 360 minus 28, which would give me 352. That's how much the major arc is. It's 352 out of 360. Almost the whole thing. And we're going to multiply that by 20 pi. Once again, you'll have to round. For this one, you should get about 18.4 pi inches. So be careful. Make sure you're plugging in the correct angle measures. Okay, last one of these, number 4. Okay, so for this circle, I'm going to draw 2 diameters. We are going to be looking for this arc right here, that bottom arc right there. Okay, this dimension right here, and that's just the little radius, is going to be 7 meters. And then this arc measure here is going to be 42 degrees. So you're going to have to think a little bit on this one. Okay, first thing, we want to find the circumference of the whole entire thing. Tells me the radius is 7. So what is the circumference of the whole circle? 7 times 2, which is 14 pi. So all the way around would be 14 pi. Now, what I need is I need to know what chunk of the circle I have. So what I need this measure right here, and I don't have that measure. I have this measure. How am I going to find that measure? Okay, remember how we said the arc measure is the same as the interior angle measure? And then Elijah said, well, these are vertical angles, so if this is 42, then this is 42, which means that arc is also 42. So we're going to do 42 over 360 times 14 pi. And if we round that, we should get about 1.6 pi meters. So that's kind of the main focus of what's new today. You guys have questions on those ones? Okay, the last few examples are going to be kind of more along the lines of what we did yesterday. So looking for missing angle measures or arc measures. So let's draw a nice big circle, circle O. So a circle with center O. And we are going to draw 2 diameters again. One of them is going to be A, B. The other diameter is going to be E, D. And then we're going to draw a radius C, down like that. Okay, and then some of the information that we're going to have. COD is congruent to DOA. And then the measure of arc BC is 28 degrees. You know, we talked about this a little bit yesterday, that I think probably the easiest thing to do whenever you have a problem like this, fill in as many or maybe even all the angles that you possibly can. So keep in mind that the central angles are going to be the same as the arc, the measures of the arcs. So if I know the measure of the arc, I know the measure of the angle. So if I know the measure of angle BOC is 28, what angle could I find next? ED. So ED isn't an angle, ED is a line. So E, you said EB? This angle here? Okay, so I'm glad you mentioned that. So EOB, if we name it correctly, EOB and AOD, they are vertical angles, so those are congruent. Leo, did you have an idea of how to find?
Yeah.
Go ahead.
You can use semicircle EBD, and
EBD.
And then you can take 180 degrees minus 28 degrees, and then you would divide that number by 2 to get angle COD and angle BOE.
Excellent. Okay, so this is a straight line. And you could either do this with these bottom 3 angles or these ones here. Works out the same way. But that's a straight line. So 180 minus that 28 degrees, okay, is going to give you 152. Okay? Those angles are congruent. So they're the same. So you take 152 divided by 2, you get 76. So actually, all of those are 76 because they're all congruent. Now I just need to find angle EOA. You could totally do that. You could add them all together, subtract it from 360. I think there might be a tiny bit easier, simpler way. Okay?
180 minus 76.
Maybe a little less than that. Just do 180 minus 76, which would give you 104. Okay, now I have all of my angle measures. Keep in mind those are the same. It's going to be the corresponding arc measures. So here are the things we want to find. So I'm just going to copy them all down. We'll go back and fill them in. We want to find the measure of angle COD. the measure of angle EOB, the measure of arc EA, the measure of arc ECA, and the measure of the arc EAB. The measure of angle COD, the measure of angle EDB, the measure of arc EA, the measure of arc ECA, and the measure of arc EAB. So what's nice about filling in the angle measures is now I just kind of have to identify these pieces and throw the answers out there. So if I start with COD, we have that one labeled. What is the measure of angle COD? 76. What about the measure of angle EOB? EOB. It doesn't look like it does it. EOB. Also 76. Okay, so those are angle measures. Now we're talking about arcs. So the measure of arc EA. Now let me challenge you guys. Bring back something from yesterday. How do I know which way to go? Do I go from E to A this way, or do I go from E to A this way? It's the smaller one. This just has 2 letters. So you're just going to go straight from E to A. So what is the measure of arc EA? 104. Now this one is saying I want ECA. So see how we throw that extra letter in there. So still going from E to A, but going the opposite direction. 2 ways you can find the measure of arc ECA. What's one of them? .360 minus 104, or add all those together. Yeah. Either way, you should get 256. And then lastly, the measure of arc EAB. Same idea, right? You could either add all of those together, or 360 minus 76, and you should get 284.